Between 2016 and 2018, Union Pacific took delivery of brand new locomotives worth over $4 million each, the most advanced diesel units money could buy, fresh from the factory floor. Within just a few years, every single one was scrapped. Not sold, not stored, destroyed. A $250 million investment reduced to salvage metal at barely $350,000 a unit. It sounds like corporate madness. But the real question isn't why Union Pacific destroyed them, it's what made keeping them even worse. A modern mainline locomotive is one of the largest single investments a railroad can make. For Union Pacific, each SD70AC T4 locomotive carried a price tag of $4.05 million. Multiply that by the full order, 65 units delivered between late 2016 and 2018, and the capital outlay reached roughly $263 million. That figure appears in SEC filings, not just industry rumor. This was not a speculative gamble or a sideline project. It was a core fleet upgrade, financed through a lease purchase arrangement with a 7-year cash flow schedule. The deal included a 24-month full powertrain warranty and built-in maintenance guarantees, but the bulk of the cost sat squarely on Union Pacific's balance sheet from day one. On paper, the numbers made sense. The railroad depreciated its new Tier 4 fleet over 12 years, spreading the cost across future earnings. By the end of 2023, the remaining book value per locomotive hovered around $1.5 million, with a total net fleet value of nearly $98 million. But these figures only tell part of the story. Every dollar spent was meant to buy not just a machine, but years of reliable service, thousands of miles, countless trains, the backbone of daily operations. When a locomotive fails to deliver on that promise, the loss is not just theoretical. It is real money, tied up in steel, electronics, and software that cannot be made to work as intended. For Union Pacific, the capital investment in these units was a bet on the future. A bet that within a few short years would be called into question in the most public and costly way possible. Union Pacific's reach stretches across 23 states, with more than 32,000 miles of track and a locomotive fleet that, at its peak, has numbered over 8,300 units. In this environment, a single locomotive isn't just a piece of equipment, it is a moving part in a tightly orchestrated system, where every delay or breakdown can ripple through hundreds of trains. The railroad's mechanical department, led by a centralized team of engineers, mechanics, and support staff, is responsible for inspecting, repairing, and keeping thousands of these machines in service. Their mandate is clear: maintain a 90% availability rate across the active fleet. That figure isn't just a target on a spreadsheet. It is the difference between meeting customer schedules and losing business to competitors. To achieve this, Union Pacific relies on a network of major service shops, regional maintenance hubs, and mobile response crews. Locomotives are cycled through preventive maintenance every 90 days, with detailed inspections and overhauls scheduled at set mileage intervals. Any unit that drops below the reliability benchmark draws immediate attention from the mechanical leadership, who track performance metrics in real time. For a railroad this size, even a small dip in availability can lead to missed connections, crew overtime, and cascading costs and lost revenue. When new locomotives are introduced, the expectation is that they will not only meet emission standards, but also match or exceed the reliability of the units they replace. Persistent defects aren't just a technical headache, they threaten the entire operating model. In this world, a locomotive that can't be trusted to run day after day isn't just a disappointment. It is a liability the company can't afford. The centerpiece of Union Pacific's fleet renewal was the EMD SD70AC T4, a locomotive that embodied the industry's most ambitious attempt to marry horsepower with environmental compliance. Built by EMD, under the Progress Rail and Caterpillar umbrella, this machine was designed to meet the EPA's strict Tier 4 emission standards without sacrificing the pulling power demanded by mainline freight. Union Pacific's order called for 65 of these units, numbered 3013 through 3077, with the first arriving in late 2016 and the final deliveries wrapping up by the summer of 2018. Each locomotive represented a leap of faith in both technology and regulation. A 4,500 horsepower AC traction road switcher meant to anchor the railroad's high-priority routes. On paper, the SD70 ACE T4 checked every box. It promised cleaner exhaust, lower nitrogen oxide emissions, and the muscle to haul long trains over mountain grades. The units came equipped with advanced selective catalytic reduction and diesel particulate filter systems, features that set them apart from the older Tier 3 fleet. For Union Pacific, this was not just about compliance, it was about staying competitive as emissions rules tightened and public scrutiny grew. The contract included a 24-month powertrain warranty and a maintenance guarantee, signaling confidence from both the manufacturer and the railroad's own procurement team. The delivery schedule was tight, with batches arriving every few weeks at major shops like North Platte and Ogden. Engineers from Progress Rail worked side by side with Union Pacific's mechanical staff, walking through acceptance tests and system calibrations. The expectation was clear. These locomotives would serve as the backbone of daily operations, handling everything from high-speed intermodal to heavy manifest freights. For the railroad's technical leadership, bringing in the SD70 ACT4 was not just a business transaction, it was a bet on the future of freight rail. Yet as each new unit rolled onto the property, the promise of cutting-edge reliability would soon be tested in ways no one fully anticipated. Within months of the first SD70 ACE T4s entering service, a new pattern began to surface in the field, one that couldn't be explained away as teething trouble. Shop tickets started piling up, each one tracing a similar arc: mainline shutdowns, unexpected derates, and error codes that sent crews scrambling for the manual. Engineers reported units stalling in the middle of priority runs, sometimes with no warning beyond a sudden drop in power and a flurry of alarms on the cab display. Detector logs from North Platte and Ogden flagged the same handful of locomotives repeatedly, documenting unscheduled stops and forced resets that left trains idling for hours. Crew testimonies filtered up the chain, first as isolated complaints. Unit 381 keeps shutting down at throttle 8, or 335 won't hold power on the grade, but soon as a chorus. Radio chatter captured the growing frustration, seasoned engineers describing the new Tier 4s as unreliable, with some calling them shop queens after just a few months on the roster. Shop foremen tracked the downtime, noting that these units were spending double or even triple the expected hours out of service compared to the older fleet. By the end of the first year, detector data showed a spike in emergency shutdowns, multiple units logging more than 5 unscheduled failures apiece, before even reaching their first scheduled overhaul. What began as scattered anecdotes hardened into a documented problem. Maintenance logs, crew reports, and detector records all pointed to a systemic issue, not an unlucky batch or a few bad sensors. For a railroad built on reliability, every day a new locomotive sat dead on the main line was more than an inconvenience. It was a warning that the promise of cutting-edge technology might be unraveling on the rails. Technical teams began tearing into the SD70 ACE T4's failure record, searching for a common thread behind the shutdowns and error codes. The first clues pointed to the emissions hardware. The Tier 4 package, selective catalytic reduction paired with a diesel particulate filter, introduced more than just cleaner exhaust. Field tests, including a dynamic analysis by the National Rail Research Institute, measured a 6 to 8% increase in unsprung mass compared to earlier models. That extra weight concentrated around the trucks upset the suspension geometry. Engineers documented hunting oscillation at higher speeds, a lateral sway that not only threatened ride quality, but also increased track wear and risked regulatory intervention. The after-treatment system, meant to reduce nitrogen oxides and particulates, brought its own headaches. Shop logs noted repeated diesel particulate filter regeneration stalls and rising exhaust back pressure, especially under heavy load. In several cases, the SCR catalyst failed to dose correctly, triggering derate events and forced shutdowns. Mechanics traced these symptoms to a web of new sensors and control modules that, while advanced, were not fully tuned for Union Pacific's demanding operating profile. Software integration proved equally troublesome. The engine control unit, loaded with firmware designed for the emissions package, clashed with Union Pacific's distributed power protocol. This mismatch generated spurious fault codes and, at times, cut power unexpectedly during remote control operations. Even as Progress Rail issued firmware updates and engineering change orders, the fixes only chipped away at the symptoms. The underlying problem, hardware and software designed in isolation and then forced to work together in the real world, remained stubbornly unsolved. Each failed attempt at a remedy deepened the sense that these units, despite their price tag and promise, were fundamentally out of step with the railroad's needs. Progress Rail's engineering team rolled out a series of technical bulletins, each one promising a fix for the mounting problems. Union Pacific's shops received firmware patches aimed at smoothing out the handshake between the engine control module and the railroad's distributed power system. The most ambitious update introduced a new protocol that, according to field trial data, cut spurious derates by 40%. At the same time, service bulletins instructed mechanics to swap out faulty NOx sensors, recalibrate SCR dosing pumps, and install reinforced DPF brackets to handle the extra vibration. Each change required hours of labor and pulled units off the main line for days at a time. Engineering change orders, ECOS, arrived in waves, sometimes faster than crews could implement them. Mechanics at North Platte and Ogden worked side by side with Progress Rail's field teams, swapping out circuit boards, flashing new firmware, and logging every attempted remedy. Shop foremen tracked the rising costs, parts, overtime, and lost mileage, all stacking up against the original promise of a low-maintenance, high-uptime fleet. The fixes chipped away at the most glaring issues, but the core problems persisted. Every retrofit brought diminishing returns, and the units continued to cycle in and out of service at rates far above the fleet average. For the teams on the ground, it became clear that no amount of patchwork could turn these locomotives into the reliable workhorses they were meant to be. The economic reckoning was no longer a distant threat. It was becoming an everyday reality. Finance analysts inside Union Pacific's headquarters began tracking the numbers as the SD70 ACE T4 units cycled through the shops. The data was stark. Mean time between failures on these locomotives dropped below 250 hours, barely a third of the expected industry benchmark. Availability, the percentage of time a locomotive is ready for service, hovered near 78%. For a new fleet, that figure should have been well above 90%. Every mile run by these units demanded 3/4 of an hour of maintenance. Nearly double the labor intensity of the older Tier 3 engines. Each mainline shutdown triggered a cascade of costs, with a single event averaging $12,500 in crew overtime, replacement power, and lost train slots. Maintenance logs documented more than 100 emergency stops in a single year, pushing the cost curve higher with every incident. What began as a technical headache quickly became a financial hemorrhage. Every failed run was eating into the bottom line. The numbers stripped away any illusion of a manageable problem. These locomotives were not just unreliable, they were actively draining cash from every corner of the operation. Progress Rail, the builder behind the SD70 AC T4, did not ignore the mounting troubles. Public statements from the manufacturer acknowledged the reliability concerns and confirmed that warranty teams were dispatched directly to Union Pacific's main shops. For nearly 2 years, engineers from Progress Rail worked alongside Union Pacific mechanics, issuing a steady stream of technical bulletins and engineering change orders. The service scope was clear. Warranty coverage extended to parts and labor for the powertrain, along with software updates and select hardware retrofits. But the boundaries of that support soon became apparent. The original equipment manufacturer's responsibility was limited to the terms spelled out in the contract. Anything beyond standard warranty, especially the ripple effects of recurring shutdowns or system incompatibility, fell back on the railroad. Even as Progress Rail's field teams swapped sensors, recalibrated dosing pumps, and flashed new control firmware, the fixes only addressed specific symptoms, not the underlying integration issues. The manufacturer's willingness to stand behind its product had limits, and once those were reached, Union Pacific was left facing the full weight of the problem on its own. The partnership could patch and advise, but it could not transform a fundamentally mismatched machine into a reliable workhorse. That gap between what the original equipment manufacturer could deliver and what the railroad required would soon force a decision no one wanted to make. On December 15, 2021, Union Pacific's board gathered to confront a reality no executive wants to face. The numbers on the SD70 AC T4 fleet no longer added up. A formal memorandum landed on the directors' desks, laying out the cold calculus. The cost-benefit model showed that every additional dollar spent trying to keep these locomotives running would be lost for good. Future repairs, mounting downtime, and lost freight revenue had already outpaced the unit's salvage value. The chief mechanical officer, backed by finance and fleet maintenance, recommended a full write-off. The board vote was unanimous. In a single session, assets worth tens of millions were authorized for disposal, their remaining book value to be erased from the balance sheet. The decision was as stark as it was final. End the bleeding now, accept the loss, and move forward. What looked like corporate waste on the surface was, in fact, the least damaging option left. The board's approval set off a chain reaction. Locomotives shifted from active service to storage, then to the hands of third-party recyclers. The episode sent a clear message through the industry: even the most advanced, most expensive equipment can become a liability if it doesn't deliver in the real world. In the end, no amount of technological promise could outweigh the hard math of operational failure. Trade journals wasted no time dissecting Union Pacific's decision. Railway Age and Progressive Railroading labeled the SD70 ACE T4 rollout a commercial disappointment, pointing to the public withdrawal and the abrupt end to a program once billed as a technological leap. The industry took notice when, in May 2019, Norfolk Southern canceled its own pending order for 10 SD70 AC T4 units. Their official statement cited reliability concerns, referencing Union Pacific's experience as a cautionary example. Analysts debated the scale of the misstep, with some calling it a warning for any railroad betting on unproven emissions technology. Competitors quietly tightened their own procurement standards, while manufacturers faced pointed questions about real-world performance versus factory claims. The fallout rippled through boardrooms and shop floors alike, reshaping how new equipment would be vetted and how much risk any railroad was willing to accept in the name of progress. Once the board gave the order, the SD70 AC T4 fleet was pulled from service and moved into storage, waiting for a final destination. Union Pacific signed contracts with third-party recyclers to dismantle the units for scrap. Each locomotive, once valued in the millions, now fetched an average salvage of about $350,000, a fraction of its book value. The process was methodical. Recyclers stripped out usable components like traction motors and prime mover blocks, reselling them into the parts market. The rest, steel frames, copper wiring, and electronics, was cut down and sold by the ton. Scrap receipts document the recovery, but the numbers made clear that most of the investment was gone for good. For Union Pacific, this was less about recouping losses and more about stopping the financial drain, closing the books on a costly experiment that never paid off. Union Pacific's procurement team did not just walk away from the SD-70 ACT-4 episode empty-handed. In the wake of the scrapping decision, the railroad rewrote its playbook for buying and fielding new locomotives. Every new order now faces a 30-day field trial before full acceptance, a real-world test that goes far beyond the old factory checks. Extended warranties have become standard, with manufacturers required to cover not just the powertrain, but also software integration and emission systems for longer periods. In 2024, Union Pacific announced a $1.2 billion modernization deal with Wabtec, shifting focus from unproven new builds to upgrading proven AC 4400 units already in the fleet. The lesson is clear in every new contract. No locomotive enters service until it proves itself on Union Pacific's own rails, under the same stresses it will face in daily operation. Procurement managers now treat field validation and lifecycle support as non-negotiable, building in safeguards that aim to prevent history from repeating itself. In today's rail industry, the price of progress can outstrip logic itself. When a $4 million engine becomes a liability, even giants must cut their losses. Union Pacific's decision exposes a brutal truth. Innovation means nothing without reliability. As technology races ahead, the real risk is not falling behind. It is betting big on the wrong future. What do you think? Is this caution or catastrophe? Let me know in the comments.